Hello, Algebra Scholars, and welcome to Factoring. This is the first part of 5.1. It's on Greatest Common Factors, GCFs. Before we dive in, let's talk about the first rule of factoring. We're going to think about this every time we're asked to factor, and that is to find the greatest factor that is common to all terms and factor it out. And this greatest factor, not surprisingly, is called the greatest common factor. We'll just call it the GCF. It's very typical to think about a GCF as being a monomial, but it can just as easily be a binomial or even a trinomial, although we won't see those in this course. In this first example, the greatest factor that's common to all three terms is a 4, and if we factor out a 4, the factor left in the first term is x squared, the factor left in the second term is 2x, and the factor left in the third term is plus 4. And that problem is completely factored. The greatest common factor in the next one is a 5. We factor that out, and we are left with x squared minus 2y plus 1. Notice that we can very easily check these problems simply by distributing, by undoing factoring. And if we multiplied the 5 through, we would see that we get back exactly what we started with, which is what we're supposed to do. Now this next one's a little trickier. The greatest common factor here is xy. The factor that's left over in the first term is a y, the factor that's left over in the second term is an x, and the factor that's left over in the last term is x squared y squared. In these last three examples, we're looking at a greatest common factor that's a binomial. Notice what's common to both terms in this first example. They both have a y plus 4 in it, and that y plus 4 is a greatest common factor. It's a binomial greatest common factor. The factor that's left over in the first term is an x, and the factor that's left over in the second term is a 2. And so we have completely factored this problem. The GCF in the next example is also a binomial. It's 2x minus 7. The factor left over in the first term is 3y, and the factor left over in the second term is a 5, minus 5. And then finally, the binomial GCF is z plus 2. And then what's left over is 15xy in the first term, and then be careful here. There has to be a factor left over. We can't say there's nothing. So what's really there is a minus 1. And that's how we do GCFs, whether they're monomials or binomials.